AP Chemisters, this is Mrs. Vanderwall bringing you sort of another edition of Blank Wall. The purpose of this video is to help you to practice doing your redox balancing equation. So for this problem I have up here, problem 43, you do have in your notes, this is the last one that we have on your packet that I didn't actually cover in class. I would get out a piece of paper and copy down the main ones. If I were you, I would write down the reactions, try them yourself, so pause this, and then I will come on with my explanations. So try these on your own. I would have your notes handy with the rules and keep going through them every time and commit those rules to memory. So here, problem number 43. Why don't you go through, like what we've done in class, go through those rules on your own, pause this, and then I'll come back with it. All right? Go ahead and pause. Okay, the first thing you have to do is assign oxidation numbers to everything. And going through our list, is anything in its free state? And the answer here is yes. Chlorine is in its free state, so I'll put a 0 with that. It is not in a compound, the diatomic element. Another rule was the monatomic ions have their own charges. So if you notice that chloride here is a monatomic ion and chromium is a monatomic ion. So there is its oxidation number. So the last one to deal with is dichromate. And if you know that oxygen is -2, then you can certainly solve for chromium. So 2 times chromium plus 7 times, I love my board. Have I closed that recently? I'll put it on here. So 2 times chromium plus 7 times -2 equals -2. So 2 chromiums plus minus 14 equals -2. Subtract or add 14 to both sides. So 2 chromium is equal to 12. So chromium is equal to plus 6. So let me erase all this and put a plus 6 up by chromium. At least I think I'm going to erase all this. There we go. Okay, so this is plus 6. So chromium is plus 6, oxygen's -2, chlorine's -1, chromium is 3+, and chlorine is 0. So what we need to do is now find our half reaction. So let's do, I don't care, oxidation first. So oxidation is where the oxidation number increased. So when it went up, it looks like the chlorine did. So chlorine goes to, chloride goes to chlorine. Now, if you look at your next rule, it says, okay, balance your elements first. All right, so I don't have the same number of chlorines on both sides. I'll put a 2 there. Balance your oxygens with water. I don't have any oxygens. Balance your hydrogens with H+. I don't have any H+ or hydrogens. So the last part is to balance the charge using electrons. Which is my most positive side? Well, you look here, 2 and -1, okay, is -2 charge. And on the right-hand side, it's 0. So 0 is more positive than -2. So I'm going to add 2 electrons. Okay. So what about reduction? What went down? It looks like chromium went down. It went from +6 to +3. So let me write that down. So here's Cr2O7 2- going to chromium 3+. Okay, are my chromiums balanced? The answer is no. I have 2 on the reactant side, 1 on the product side. I'll put a 2 here. Are my oxygens balanced? No, I have 7, so I need to add 7 H2O. Are my hydrogens balanced? No, I need 14 of them now. And now we have to look at charge. I have 14 minus 2, which is a +12. I have 2 times +3, which is +6. So I need to add 6 electrons over here. Okay? All right. So now I need to add the 2 together. And I'm looking at the oxidation reaction. I am losing 2 electrons, but I'm gaining 6. I can't do that. So I have to multiply this by 3 and then add everything through. So let me add the 2 sides together. I get 6 Cl- plus 14 H+ plus Cr2O7 2- to make 3 Cl2 plus, where am I? 2 Cr3 plus 7 H2O. Is there anything that appears on both sides? The answer is no. So my last thing I need to do is make sure it's balanced in both atoms and charge. Notice this is an acid, so I don't have to do anything funky there. So here I have 6 chlorines here, 6 chlorines here. I have 14 hydrogens here. I have 14 hydrogens here. I have 2 chromiums here. I have 2 chromiums here. I have 7 oxygens. I have 7 oxygens. Let's check out the charge. I have 6 minuses and 14 pluses and 2 minuses. So that adds up to, it looks like plus 6. Over here, I have 0 plus 6 plus 0, which is plus 6. So everything worked out as far as the atoms and the charge. Okay, so why don't you go get a piece of paper now, if you haven't done so already, and I'll put up the next one. Okay, so here is another one for you to work on. So why don't you try this, going through all the rules like I showed you, and come back when you're ready. Okay, the first thing I did was put my oxidation numbers up there, so you can see I got plus 4, minus 2, minus 1, plus 2, and 0. Again, iodine, as I2, is a free element by itself. It's diatomic, but it's elemental iodine, so it's 0. What went up? What became more positive? It's your iodine. So my oxidation is I minus going to I2. I need to balance my iodine, so I need to put 2 there, and then I need to balance the charges. Notice I don't have any oxygens or hydrogens to worry about. My next one will be reduction. It goes from plus 4 down to plus 2. And I need to balance my oxygens by using water. I need 2 of those. I need to have 4 H pluses. And now I need to look at my charges. Here's my 4 plus. Here's my 2 plus. So I need to add 2 electrons to make that all work out. Hey, what do you notice? Those 2 electrons already work out. I don't need to multiply anything. I gain 2 electrons. I lose 2 electrons. Life is good. Now let's just add everything together. Let me scroll this up a little bit. And let's put 2I2 plus 4H plus PbO2 yields I2 plus Pb2 plus 2H2O. Once again, this is in an acid condition, so I don't need to do anything funky. Don't worry, I'll come up with a base shortly. And now we just are left with balancing. So I have 2 iodines, 2 iodines. I have 4 hydrogens, I have 4 hydrogens. 1 lead, 2 oxygens, and 2 oxygens. So my atoms are balanced out. Now I'm left with doing charges. I have 2 minus plus 4, so that's equal to positive 2. Over here it's positive 2. My charges all balanced out. How's this going for you? Hopefully it's getting a little bit easier. Let's try another one. Oh, this is a good one. See what you can do. Pause this, try it, and we'll see what happens. Okay, hopefully you got the oxidation numbers that I did. Sulfur went from a plus 4 to plus 6, so it became oxidized. So let's check this out. We have SO3, 2 minus, going to SO4, 2 minus. Are my sulfurs balanced? Yes. Are my oxygens balanced? No. So I have to add an H2O, just one of them, because now I have 4 oxygens on both sides. Now I need to balance my hydrogens. So I put 2 over there. And now I need to add some electrons. Which side is more positive? Well, right now this is -2. Right now this is 0 between those 2. So I still have to add 2 more electrons over here. Okay. My reduction is permanganate. I hope by now you're kind of familiar with permanganate being reduced. I have to add 4 waters over here. So I have to add 8H plus over here. And if you check out your math, I believe I still need 5 electrons. Notice it's the same reduction equation every time. But what happens here? I have 5 electrons being gained, 2 electrons being lost. It doesn't work out. I need to multiply this by 5 and this whole thing by 2. So let's see what happens when I do this. Are you ready? So we have 5H2O plus 5SO3 2 minus, plus 2 times 8 is 16, H plus 2 Mn4 minus, making, let's see here, we have 5 SO4 2 minus, plus 10 H plus, I'm running out of room, plus 2 Mn2 plus 8 H2O. So what do you notice here? Let me scroll this up. What do you notice here? We have a couple things on both sides of the equation. I see I have water here, and I have water here. I see I have H plus, let me use black, I guess, here, and I have H plus here. So I have to combine like terms. I have 5 waters. I'm going to make this 3 H2Os. I have 16 hydrogens and 10, and I cross this out and make this 6 H plus. So let's kind of all put this together. We have 5 SO3 2 minus plus 6 H plus 2 MnO4 minus makes 5 SO4 2 minus plus 2 Mn2 plus 3 H2O. Now what do? We make sure that this works out. Let's check this out. We have 5 sulfurs, 5 sulfurs. Watch your oxygens. We have 5 times 3 is 15, plus 8 is 23 oxygens. Your 5 times 4 is 20, plus 3 more is 23 oxygens. Good. We have 6 hydrogens. We have 6 hydrogens. 2 manganese and 2 manganese. So let's check out our charges next. Here we have 10 minus plus 6 minus 2. If you add that up, it looks like what? Looks like 2, isn't it? 10 plus 6. I'm sorry, 10 negatives. That's what, minus 4. Oh, sorry. It is minus 6. Excuse me. Let's check over here. We have 10 and we have 4, which is negative 6. So that works out perfectly. I think I'm going to run out of time, so I'm going to stop this one and start up a new video shortly. Okay? So go to the next one.